Okay, so I'll give you an overview of the SpiNNaker system and the SpiNNaker tutorial that we want to give this morning and afternoon. So you may all have seen the SpiNNaker chip already. Here it is again. The SpiNNaker chip is essentially a multi-core chip, 18 cores on the chip. We tend to use one as a monitor to control the system, but you can access all the other 17 or 16 depending on how the manufacturing went. The important bit of the SpiNNaker chip is this router in the middle, which can send these multicast packets to lots of other chips that are connected together. On each core there is 64K of local memory and 32K of instruction memory, so you don't have a lot to play with, but there's lots of cores, so you can split things across them. And of course, this is designed to simulate neural networks, so that's exactly what we do. We want to simulate small bits of computation in lots of places. There's 128 megabytes of SD-RAM as well, which is bonded on top in a single package. It consumes about 1 watt per chip, so it's reasonably low power for a computing system. The cores are about 200 megahertz as well. So we tend not to use single chips, we tend to use boards. We have 4-chip boards, which are very simple, probably easy to plug into your robots though. We have these 48-chip boards, which is what most people end up using. And if you use the remote systems, this is the sort of access you'll get to 48-chip boards, not 4-node boards. And of course, if you're using the remote systems, you'll actually get access to bigger machines. So we have various configurations that you can build these boards into. This is a 24-board system on the left here. There's a whole cabinet which consists of 5 of these 24-board systems stacked up. These systems are all configured so the boards are connected together in a complete torus. Basically, the connectivity is as much connectivity as possible. Of course, the machine that we've most recently put together is this million-core machine. This animation in the bottom here is actually us booting this machine, so we're counting the cores on the machine to check that there were actually 1 million cores. We recently had a switch-on event, and that's where we showed this. This is a recording of the turning on the machine. I'm not doing it live. People are using too much of it now. It does reach 1 million. I think it's an animated GIF, so of course it loops. Yeah, and we got there on the day, so that is good. So what sort of things can you use SpiNNaker for? Or what sort of things have people used it for in the past? Of course, computational neuroscience. SpiNNaker is, we're part of the Human Brain Project, so people are doing computational neuroscience. I know there's been talks about this here as well. People have been doing this sort of thing. This in particular was a 80,000 neuron network, and I think it's got 0.3 billion synapses, something of that sort of nature. And we were able to simulate that on SpiNNaker. Admittedly, we had to slow it down quite a bit, but we're working on the software to try and improve that. So, what are the sort of things? Yeah, other sort of neuroscience. There's a PhD student who's working on having an ear model on SpiNNaker. So this actually has all the components of the ear. So rather than just sending spikes, it actually takes an audio signal in at one end, converts that into a spikes through the processing that the ear would perform. Processing, yes. So it tries to simulate this. The good thing about SpiNNaker being general cores, of course, is this is actually run on the SpiNNaker machine. So in theory, although we haven't got this far yet, you could feed an audio signal straight into the SpiNNaker machine live, and it could be processing that, turning it into spikes and feeding it into your neural network. I think for now it's loaded by spike source arrays, but of course, not spike source arrays, it's loaded up in advance onto the machine, into the memory, and then it's read off there, but we could stream it in if necessary. Some other bits students have been doing is working on how the eye works, trying to set up neural networks of that sort of nature as well. So it's a fair bit of neuroscience work. The other thing, SpiNNaker is designed to run in real time. So the idea is that you could connect it up to your robots. It's got quite a lot of connectivity options in there as well. There's Ethernet, fairly basic, but it also has various connectors on the edge of the board, which you can connect to robots. There's a push bot in the lower corner here, which is one that we've particularly focused on because we've actually got an interface board that connects directly into SpiNNaker, and then you can wirelessly connect to your push bot, make it do all sorts of fun things, like here you can see it following a light, nice and easy. But yeah, the idea is you can do that. We can also, more recently, we've been able to plug into the neurorobotics environment within Human Brain Project. So this is an example of a robot which is looking for a red light and it follows it, but this is all done in a virtual environment. So the let me think, yeah, the hope is that the environment runs in real time as well. These things are not tightly coupled, so it's just sending spikes between the two things, but it works reasonably well, even though the environment tends to be a little bit slower than real time, but you can get a reasonable reaction out of it. And of course, this has got a SpiNNaker backend on it as well. Other things that we've been looking at, I think you may have seen some of these with Steve talking about things as well, I'd imagine. People have done Sudoku Networks, so it's basically taking neurons and using them for not really brain-like computation, but for doing other fun things. So solving constraint satisfaction problems, and of course Sudoku is one of those. So there's various problems that have attempted to be solved. Another one some of our students have been working on is trying to play the game of Breakout. This is another example where we run the virtual environment on SpiNNaker, and then you can sort of get it to learn how to play Breakout. So there's a bat moving along the bottom here, and it's the controls, I think, is it's just got left and right. So it has to move this bat to try and maximize the score at the top. That's its sort of rule. When the ball falls off, I think it loses a score. And so it's obviously trying its best to not do that, and eventually it's learned to do this, which is pretty impressive, I think. Another student's been playing with structural plasticity, so of course is looking back at good old MNIST again. This is doing MNIST with pure structural plasticity. So I don't think this is using, I think in this case it wasn't using STDP at all. I think there are cases where we can also add STDP on top, and it can do this. So you can sort of see this, we're feeding it lots of these digits in, and it's eventually working out structurally where the connection should be made, and then it can recognize the digits quite well. So there are various ways to access the SpiNNaker system. Obviously, you could have the physical boards, but we don't have that many of them to give out, especially not since we built a 1 million core machine. We're now running out of 48 node boards to lend to people. So there are two ways to access SpiNNaker remotely. One of them is to use this batch processing system via the Human Brain Project. Basically, you can submit a script, let it run, come back to it whenever you want to later on and see what the results are. You can then download graphs and things of that nature, all your results, process them offline. A more recent development is we've installed Jupyter Notebooks in a similar way to the Brainscale system. So you can now access in a more interactive way the SpiNNaker system as well. And that's accessing the 1 million core machine you can see here. So the servers are all running in this end cabinet, and they're obviously all directly connected to the SpiNNaker system. Obviously on the Jupyter system, you can then draw all your graphs live and actually see them coming out. This is nice. So the idea of the tutorial this morning and afternoon, again, with the same thing, both sessions, will let you access SpiNNaker via the Jupyter Notebook, show you how to access that. You'll then learn how to use Pine, similar to Brainscales, we use Pine as a neural network language. So how to use Pine in general, and then how to run that on SpiNNaker. And then hopefully you'll be able to run some of your own experiments on SpiNNaker. We've got some example tutorials that you can go through and give that a go. But of course you can experiment with anything you want. It's the Jupyter Notebook, so you can write your own scripts, do as you wish. Okay.
Thank you, Andrew.